All right, guys. So this is going to be a marketing analysis, a case study, where what we're doing is we're going to examine a business process that's actually currently being performed in Excel. And what we're going to do is we're going to show how that can be efficiently converted to R. And we're going to see a whole lot of benefits in terms of just all sorts of good stuff, meaning we're going to be able to work with big data and very efficiently and effectively. And there's going to be a lot of things that we're going to see here that are, reasons why we want to use R as opposed to Excel. We'll also be talking a little bit about this thing called a correlation funnel. So just keep that in the back of your mind right now. The idea here is we're going to be trying to let insights come to us rather than do the kind of pivot table approach where we're just investigating features and features and features on end and taking a long time to do exploratory analysis. All right, so this learning lab, the structure, it's gonna be a little bit longer today because of the amount of content that we have, but it's gonna be really powerful. So hang in there. We've got 50 minutes of presentation. We've got about 10 minutes for Q&A, and we're your hosts. David, you wanna introduce yourself?
Sure, David Curry. I have a business called Sure Optimize, and we focus on marketing analytics and search engine optimization.
Cool. And you know me, Matt Dancho. I'm the founder of Business Science, instructor at Business Science University, and I love to teach. And I'm committed to helping you go wherever you want to go with data science. All right. So to get started here, I want to show you guys where the presentation materials are located. What I want you to do is I want you to write down this website here. It's github.com/business-science/presentations. And David, if you wouldn't mind maybe putting that in the chat for everybody.
All right.
What I recommend though is don't do anything with this yet, because what I'm going to be doing in this presentation is more showing you what the code is and what it's doing, rather than you trying to download everything right now and then follow along and get the code running. What I recommend doing is saving that until later, after you have a chance to digest the information and see what what we've got going on. So write this down and then save that, tuck this away for later. Okay. And just to show you what it looks like, so you'll know you're at the right spot if you go to this business science presentation. So this is that URL. And then right here is where the learning lab materials are. So you'll be able to download all of these. All you need to do is just click this clone or download button, and you can download a zip file, and that'll give you all of the presentations, not only for this learning lab, but all the other stuff that we've been doing over the past several years. So, all right. Getting back to the presentation. So that was where the materials are located. We also have an R cheat sheet, and this is going to be helpful. We're going to try and tie the code that we present today a little bit to some of the steps in the workflow. So if you can see that there's this workflow, we're going to do a little bit of importing. We're going to do some transformations and visualizations. We aren't really going to go into modeling, but we are going to do a correlation analysis, which is really cool. And then at the end, we're going to show you how to convert that into a report using RMarkdown. So this is the URL. This is the other one. David, if you wouldn't mind putting this one into the chat for them.
Okay. Yeah, no problem.
And once you get to it, this is where that URL will take you to this ultimate R cheat sheet. And then all you're going to do is click this download button, and that's going to download the cheat sheet for you. All right, agenda for today. So what we're going to be doing, it's kind of broken up into 3 different parts. The first piece is an Excel piece, and that's going to take 5 or 10 minutes. And what we're going to do is we're going to go through and show you how this business process is in Excel currently and some of the issues that you're going to run into. There's an issue with VLOOKUPs, which causes your file sizes to just increase exponentially. And then an issue with analyses where it's just kind of like making pivot table after pivot table after pivot table and exploring all of these different features to try and gain some insights. And we're going to see at the end of the day, R is a much better approach for that. So we're going to spend the bulk of our time on this conversion to R code, this business analysis. It's going to be a live coding session. We're going to talk about how R is awesome, of course, because it's fast and efficient for data analysis. And we're really going to be focusing on this thing called the correlation funnel, which is a really neat way to get to insights quickly. Mm-hmm. And then at the end of it, we're going to wrap it up by the plan. What we're going to do is we're going to give you a plan to go forward and learn R using our Business Science University program, which will get you up and running very effectively and efficiently as well. Okay, so with that said, let's get started. This is the first segment. We're going to be talking about this business process in Excel. This file is located if you go to that business science, and it's in this marketing labs folder. In the data, there's this Excel file right here. So what we're going to be doing is we're going to be pulling up that right now, and I actually have it opened already as a Google Sheet. And the way this Excel file is structured is it's structured like so many business processes that I've seen, where you've kind of got the step-by-step, which starts with kind of like a information collection process. So we've got step one, we're collecting some information on clients, their age, job, marital status. We're collecting information on loan history. We're collecting information from another data source on their marketing history, when they've been contacted last. And then we're collecting information on this thing called term loan deposit, whether or not they've enrolled in a program. So this case study is actually for a bank that has a marketing group, and this marketing team, what they're trying to do is determine whether or not people are going to be likely or not to enroll in a term loan, which is similar to a CD or basically it's a product that banks offer, where they would have customers that would purchase the CD and kind of put money away in it, and it grows and grows and grows over time. And it's very desirable to, for the bank, obviously, to have people enrolled in this program, because then they also make interest off of their loans. So I don't know, David, is there anything else that you think we should hit on in terms of?
Yeah, sorry, my connection got a little unstable there, so hopefully I'm not choppy. But yeah, that's exactly right. And I think the whole marketing piece to this is trying to reach out to customers to determine if they want if they're interested in a term deposit. And a term deposit is basically investing an amount of money into the bank for a fixed term or length of time, or for a fixed term at a fixed rate. So of course, banks love that because it's sort of income for them, and then they can reinvest it themselves and make money on it. So this whole marketing data set is all about reaching out to customers to determine if they want to enroll in the term loan.
Okay. So this idea here is that this business process, we're going to take some data that we know about these customers, and we're going to try and correlate it to whether or not those customers have either opted in or not opted into the term loan program. So this business process starts with step one. We're going to collect some information from a few different, say SQL databases. Step two, we're going to merge that information together in Excel using this thing called a VLOOKUP, which, if you're familiar with Excel, you probably use that quite a bit. And then step three is once it's all blended together and merged and joined, we're going to take that and then try and come up with a marketing analysis. So the first step here is collecting information. I have these color coded. So this is orange. Each of the steps are orange. Some of the general information is blue in this data set. And then this purple here, or burgundy, that's going to be the data tables. So this is our client information, and you can see we've got age, job, what is their job, what is their marital status, are they single, married, divorced, education level, and so on. So that's the client information. And you can see it's got this ID field, and that's what we're going to join on. So each of these customers has a customer ID. You can see that there's a loan history, which is whether or not they've defaulted in the past, whether or not they currently have a balance and how much that balance is, whether or not they've got a home loan or a personal loan as well. We've also got information on the bank's past marketing history with each of those clients. So that bank is keeping track of things like duration, what is the length of time from that last point of contact? Which campaign was that contact on? What type of contact was that, through a cellular service or an email, or was it unknown? And then what was the outcome of that last contact? Did they enroll in anything or not? And then finally is the subscription history of the term deposit. So for each of these different clients, they have whether or not they've previously enrolled in that term deposit program. So the idea here is, in step one, you collect this data, and then in step two, we're going to merge that information. So this client merge is where we start to use Excel's powers, and this is where we're doing that thing that's called a VLOOKUP. So the way a VLOOKUP works is, in each of these cells, you type in this, it's kind of like code in a sense, where it's got this function called VLOOKUP, and it looks up the ID and the and what I'm giving it as a column index within each of these different tables. So for this one, it's pulling information from the client info tab, and it's basically pulling in that data for each of the different IDs. So what ends up happening, and I want to take a little bit of and discuss this because it's really important to understand, is that VLOOKUPs are really difficult, especially if you're dealing with a lot of data, because there's three different reasons that I'm going to focus in on. First, when I was doing this, I can't tell you how many mistakes I made, and some of these were difficult for me to figure out, because I was trying to pull in information and I would forget to include like a $sign up here to lock in a range. That range would change, and if you don't get this perfect, you're going to accidentally pull in information that you think is correct, but it's not. So you're going to have errors in your data set. So that's the first big mistake that you're going to run into with VLOOKUPs. The second one is computationally intense. So I actually had to limit this data set to 10,000 rows out of the 50,000 rows, which is not a lot of data. So 50,000 rows, you think Excel should be able to handle it. So the second problem arises because if you think about it, it's not text that's in here, meaning married, single. It's actually functions for every single cell. Mm-hmm. So you have 10,000. So we have 10,000 rows by 10 columns. So you have 100,000 equations in here that are being stored underneath the hood. So each one of these cells has a different equation, and that causes your file size to grow exponentially. So we're talking a file size that actually jumped from 4 megabytes all the way to 7.2 megabytes, which is almost a 50% increase when I did a VLOOKUP on 20% of the data. So you can see it's not a one-to-one ratio. And what ends up happening is Excel very quickly gets to the limit where it makes it very difficult. So just for example, when I tried to do all 50,000 rows, it was like it's just kind of spun for like 10 or 20 minutes and it didn't really do anything. So I ended up limiting it to 10,000 and then it worked. But that's kind of the issue that you run into with the VLOOKUP. So in this data set, I actually only have the first 10,000 rows. You'll see that here. If I scroll to the bottom, I capped it at about 10,000. It's 10,007 here, but the first few lines are missing. So we've got our data joined, but I only have the first 20% of it. So then once you get it joined, then what are you doing in your Excel business process? Well, you're going to start kind of going through and creating these pivot tables. So this is an example of a pivot table here, and a report and a chart that is derived from that pivot table. So what we're doing here is doing something like looking at some of the different features. For example, this is our hit rate. So the number of people who opted in versus the number of people who didn't by day. And again, this one only encompasses May and June because I had to cap it to 10% of the data, or 20% of the data. And then this is a histogram, so we can see that our medians somewhere around 3.6% on average per day is what our baseline hit rate is. So then the next thing that you're going to do is you're going to start stepping through each one of those features in your data set. So the first one I'm looking at here is job, seeing if there's certain jobs that are generating higher percentages. And it does. It looks like self-employed is about 5.88% hit rate versus unemployed, which is the next, and everyone else seems to be below 4%. So there might be something there. But here's the deal. This is how you normally do analysis in Excel. You're kind of looking at every single feature, and for a big data set, this is 18 features. That could take you hours and hours to analyze that data. So we've got two issues here. We've got the VLOOKUP situation, which we're only able to look at 20,000 or 10,000 rows. And we've got the situation on the analysis end where we're going to have to go through each feature and kind of analyze each one independently. And it's just not a very good approach. So now what I want to talk about is we know that there's some issues with Excel. How do we, what solutions do we have out there? Well, we've got R, which is an amazing solution. And I'm going to do some live coding here next, but we're going to focus on two things. First, we're not going to go through every single feature, but rather we're going to let the insights jump out at us by doing a correlation analysis. That's the first one. And then the second one is we're then going to use that correlation analysis to develop a strategy and report the results in an RMarkdown document. And I'll explain what that means here in a minute. All right, before I jump into this, David, is there anything that you want to say, or is there any questions that we should handle before we jump in?
Actually, everybody's really quiet. I'm surprised. But no, I think we're good to go. Let's just keep moving on, since I know it's quite a bit to talk about. There is one question about book recommendations, but I think that's probably one we'll save for the end.
Okay, that sounds good to me. All right, so let's do some R coding. I'm going to open up. This is the R file. So if you look at this, our data structure is the exact same as what we saw here in this presentations. So in this Learning Lab market analysis, this data structure is the same here. And what we're going to be doing is basically going through that in the RStudio IDE. So the file that I have opened up here right now is called marketing_analysis.r, which is this file here, right here, this marketing_analysis.r. And I also have opened up this marketing analysis report.rmd. So before I jump into the actual code, I'm just going to run this document and show you what the end goal is first. So what this does is I hit this knit button here, and this is this RMarkdown document. It just generated a report. So this is what we're going to be putting together here today. So we've got this thing. We've got a report that is, you can imagine that this is a report that you would give to a boss that is actually generated with R code under the hood, but that boss isn't going to be interested in the R code. What they want to see is your summary of the results, what your analysis told you, and what the strategy that you developed from that analysis was. So that way your boss can ask questions, maybe come to his or her own conclusions, and really it becomes a compelling way for you to persuasively say that, hey, this is the value that I'm providing to our company. So for this particular report, what we're doing is we found that duration since last contract and success of prior enrollments are correlated to the success of term deposit opt-in, meaning whether or not that customer opted into the term deposit program. So we've got two variables that are jumping out to us. A strategy that we can develop is by targeting customers that we have contacted, that we have not contacted in the past 319 days, and those with prior enrollments and that'll yield 32% positive outcomes versus 4.3% otherwise. And how we did that was we came up with this this tool called the correlation funnel. And what features are jumping out? There's this feature called duration right here, which has a bin for, and I'll show you what bin for means in a little bit. But basically, this is the people that haven't been contacted in 319 days or longer is highly correlated to term deposit. Same thing here with P outcome. So if they've had a prior positive outcome, meaning they've enrolled in another product, they're more likely to enroll in this term deposit. So by focusing on people in these two groups here, we're able to capture about 32% yield versus 4.3% yield. So we develop a strategy based on that correlation funnel, and we're showing here that we're getting a huge yield here, which is yeses. We're getting a lot of, just by looking at around 4,000 plus 8,000, around 12,000 people out of the 45,000 people. By targeting these people, we're getting a 31% yield versus targeting everyone, which is 50,000, and getting 4.3% yield or so. So does that make sense? Anything that you think I should add there, David?
No, I think that's good. I think before you jump into the code, if you could just show the cheat sheet and then relate that to the sections of the code so people can understand the context of what we're doing.
Sure. Okay. So this is the cheat sheet. So when you download this from that R cheat sheet URL, this is what you're going to get. And in the code, so I'm just going to minimize this for right now, and I'm going to go to the marketing analysis. So this is the script file, which is a .r file. And what we're going to do is kind of step through certain portions. So the first one is going to be reading in some of the data, and that's what we're kind of doing here. So that would be under this section here, import. And then we're going to be analyzing. So we're actually going to skip some of the tidying because this data set has already been pre-cleaned. And we're going to skip right into kind of like the transformations and visualizations. And instead of doing modeling, we're going to do a correlation analysis. But this is kind of the path here. And then to produce that RMarkdown document, that PDF that I just showed you, that's going to be done in this communication step. So each one of these has links. So if I want to click like RMarkdown, for example, I can click that here, and I've got all the documentation for RMarkdown, getting started with RMarkdown, and so on.
Yeah, I'm sure a lot of you have seen this cheat sheet, but it's really cool because it shows the methodology for stepping through solving a problem, a data problem. And then within the code, it's all sort of commented, so you can kind of get a sense of if we're in the import section or phase, or if we're in the visualization stage. So just keep that process in mind as we go through the code, so you don't get too lost.
Yeah. So this is kind of what he was referring to with the read Excel sheets. This is going to be in the import, investigating the data for each sheet. So we're using this read Excel function again in the import, doing the VLOOKUP, which is using this left join function, and so on. Okay. So to get started, I'm actually going to take my session and I'm going to restart it. Just to clear out my environment, and then I'm going to clear out my console using the Control and L button. So I've got an empty console, and all I have essentially opened up is this .r file that I'm going to be working with. So the first thing I'm going to do is I'm going to load a few libraries. I'm going to load the tidyverse, which is kind of like the workhorse in R. And what that does is it loads a bunch of packages. You can see it's attaching ggplot2, which is used for visualization, purrr, dplyr. Dplyr is used for manipulation, and several other packages. The next one is read Excel. So we're just loading the read Excel package, which is going to allow us to read Excel files in. The third one here is recipes, and this is kind of an advanced package, but it's really useful for preparing data and going through kind of like a step-by-step process of adding various manipulations to it. I'm going to load the TidyQuant package, which is my package, and we're primarily going to use that for some plotting. It's got some nice themes in there. And then ggRepel is also a nice package for adding lines to show where different labels kind of connect up with their data points. So I'll explain what that means in a bit. But these are the libraries that we're going to load. The first thing that we're going to do is we're going to locate that that Excel file. So if I click that data folder, this is the Excel file that we want to pull up, and that's basically what we were looking at here. It's the Excel file that looks like this, where it has all of these sheets in here, procedure, data description, and so on. And so we want to navigate to that path. And if I wanted to navigate to it, just put some empty quotes and just start in the tab, go to the data folder and hit tab again, bank term deposit. I'm going to save that as a variable called path, and that's going to save it right up here. The next thing that we're going to do is we're going to use this Excel Sheets function, and that comes from the Read Excel package, and we're just going to supply it the path. So when I do this, what that does is it saves these sheets. So if I output the sheets to the screen, and I'm just kind of highlighting this section here, and I'm going to hit Control and Enter, you can see we've got all of the Excel sheets that are in that Excel file. And what this is going to allow me to do is then target specific Excel sheets to pull in. So when I look at this, what I can see is that there's the different steps here. And then after step 1, there's client info, there's loan history, marketing history, and subscription history. So that's the feeder data that is used to then be joined in the client merge step, and then in the third step, perform the marketing analysis. So what I can do is I can actually use these sheets to iterate through each one of the sheets and pull them into R. So if I just kind of step through this here, this bit of code looks a little complicated, but just let me tell you what it's doing. What I did was I used each one of those sheets here. So this is the sheets. I used this piece here to then map through this Read Excel and apply that that Read Excel function to each one of these sheets. So now I can actually see what's in each of the different Excel tabs. And it's going to truncate it once if it's longer than like 10 rows or so. So this is a really good way to be able to see very quickly what's in that Excel file. So I can see here that after step 1, we've got the client info. I'm going to want to read in this file. I'm going to want to read in this sheet. I'm going to want to read in this sheet and this sheet. And then I'm going to want to perform this merge, but I'll do that in R. So I'm going to convert that piece to R. So recognizing that there's only a few sheets that we want, it's this client info, loan history, marketing history, and subscription history. What we can do is just kind of extract those sheets specifically, which is what this line of code does. And it just read in each one. So I've got the client info, I've got the loan history, I've got the marketing history, and then I've got the term deposit. So that's basically these tabs here: client info, loan history, marketing history, and subscription history. And then what we're doing here next is we're going to apply this left join function, which is going to take the ID column, since they all have ID, and it's basically going to accomplish the VLOOKUP for us. So this is really cool. So that VLOOKUP was such a struggle. So what I did was, you can see it's joining by ID, joining by ID, joining by ID. So I'm using this left join and I'm doing this reduce, and it's iteratively joining each of those data frames. And I saved it as this variable called data joined tibble. So here's what it looks like here. But what I want to do is I want to pull that up in the spreadsheet format that we're probably more accustomed to. So what I did here was I just clicked on this environment variable, data join tibble, and it opened it up in this kind of spreadsheet format. And what I can do is I can filter it. So I got all the the management. I just typed in manage up here. But what's really cool is, you know how Excel like kind of did that, gave me the spinny wheel, and you just kind of stare at it at the screen because it's thinking and it's working hard to do that VLOOKUP. In 2 seconds, I got all of my data, all 48,000 rows, all of the different columns, everything joined. And you saw how that was 1, 2, 3 lines of code to do the VLOOKUP. And here's the deal. This code you can just kind of rinse and repeat. So this is basically what you need to do. You just figure out what sheets you want, and then you just run this section here where you map the path and sheet in the left join. You reduce with left join, and then you got it. Okay. So
just a quick heads up, Matt. It's about 30 after, just
okay.
as a time frame.
All right, cool. So what we're going to do is we're going to keep cruising along here. Now that we have our data in here, what we want to do is, instead of before, what we tried to do was do like a marketing analysis where we did every single variable, and we only did 2 variables, but you can imagine us doing it for all, 18 of these features, and that could possibly take forever. So what I'm going to show you how to do is the correlation funnel now. So what we're going to use is this this package called recipes. And if you want, you can get to that package here. It's right here. Whoops. Let me go to this one here. Recipes. If I click this, this is the documentation for it. And there's a bunch of references here for these step functions that we're going to use. And how this works is, what we're going to do is we're going to take our data, which looks something like this, where I've applied this glimpse function to it so we can actually see a little bit better all 18 columns. So you can see it's character data type, some are double. And the problem with this data is we can't run a correlation analysis on it. We've got to transform these variables to get them to be all binary or all numeric. So we've got to do that in a way. And what I'm going to do is use this recipes package to do that. So I'm going to comment out these first. We'll do these 3 lines where I'm actually applying some of these steps. So Control-Shift-C to comment. And what I'm going to do here is I'm going to show you there's this recipe function, there's a prep function, there's a bunch of steps applied in the middle to do some transformations, and then there's a bake function down here. So this is kind of how the recipes package works. And if I just do this section here, it's not going to do any transformation, but it's going to build a recipe. So I'm going to build this recipe object. And it doesn't have any steps applied here, but it's got a role that's a predictor, and it's got 18 variables. And then when I apply this bake for the data transformed, and I'm giving it the new data, which is going to be this data join table, what bake does is it actually takes that recipe that we built up here and actually applies that to the data. So we're coming up with a recipe, and then we're applying that recipe to a data set. So if I run this, it actually doesn't do any transformation because we don't have any steps in here in the middle. So we haven't really come up with a recipe yet. And we can verify that because this data transform variable is the same as the data joined variable. Okay. So the first thing I'm going to do is add a step. I'm going to remove this ID feature because that's not going to give us any correlation. We don't really want to know, we don't really need to know which person for this correlation analysis because that variable is not going to give us any information. So I'm going to run that, and if I run this again, we can see that now there's only 17 variables and that ID feature has been dropped. The next one is the step discretize. So what I'm doing here is I'm taking the numeric variables and actually I'm going to bin them into quantiles basically. So what that allows me to do is then assess the correlation, not of the entire numeric variable, which something like age, you can think of age as being cohorts. Some people are going to be younger, some are going to be middle-aged, and some are going to be older. We want to separate those 3 out into bins so that way we can assess those kind of like cohorts or the groups within the numeric features. So that's what this step is going to do. It's going to convert all of these numeric variables like age. And if I run this piece here, and we're going to get some warnings here because some of the variables can only be discretized into, say, 2 bins versus 4 bins or so on. We're going to apply the bake again, and then let's see what that transformation looks like. So now that age variable is this thing called a factor. It has FCT here. You can see it's bin 4. That first observation was bin 4. The second one, bin 3. Third one is bin 1, and so on. So all of the numeric variables got converted into factors or categorical data. So now that we have categorical data for everything, we can then apply this next step, which is basically it's what's called one-hot encoding. So we're going to turn all the categorical data, which is going to be features like, for example, education here, which is tertiary, secondary, unknown, and marital. And then it's even got age, which has now been binned. So these numeric variables that have been binned, and it's going to convert them into 1s and 0s. And then we're going to check out this transformation next. We're going to apply the transformation using the bake function. And when we glimpse that data, we can see that now we have a lot more variables. So we have 74 variables, and they're all binary. They're all 0s and 1s. So you can see that this is the perfect data set to apply a correlation analysis to.
Yeah, actually, can I just jump in really quick? Can you scroll back up to the recipes
Sure.
lines? I know we have a wide range of familiarity with R, but basically, Matt's, this whole, where you see line 40, where it says recipe object down to 44, he's transforming the data, the merged data set that we had, into a format that that we can do correlation analysis with, because the format that it was in before is good for maybe visualizing and doing some regular analysis, but for specifically for correlation, you want to have it in a specific format. So that whole section of code right there is what's going on. I know there's been some questions about it, so I'm just trying to clear it out.
Yeah, and I actually teach this in the 201 course, but basically we're taking this data joined, which looks like this. So it's got an ID feature, an age, some categorical data like job, marital, and so on. And it's transforming that. It drops the ID feature and it transforms the numeric features into these bins, and it's transforming the categorical features into like job admin, job blue collar, job entrepreneur, job housemaid, and so on. And it's just 1s and 0s, whether or not that occurs or not. Okay. All right. So now we're ready to do, so now that we've got this binary data set, we're ready to do some correlations. So what we want to do is we want to correlate it to this term deposit feature. So we want to correlate all of these different variables, and we're going to do that through this stepwise process. And this is a lot of dplyr. So you see these pipes. We're going to be piping that data in. So first we start with data transformed, and then we're going to do a correlation. So that's what this core function does. So you see how it says core here. If I run through this piece, what it does is it does a correlation between all of the different features, and it returns it kind of in this weird format. It looks like it's what's called a matrix with a 1-column matrix. But you can see each of these row names are each of the different features, and we've got the magnitude and direction of the correlation. So negative 0.02 is going to be slightly negative correlation. Positive is slightly positive, and so on. Okay. So the next piece is data manipulation. We're going to convert that to a tibble, which all that does is just produces this a 2-column tibble. So it converts that matrix into a tibble format, which is used in the tidyverse. Think of it like a data frame. Then we're going to rename term deposit yes. So this V1 column is going to get renamed here next. We do that. Then what I'm going to do is I'm going to separate this feature because it actually has two features in there. It's got age. So you see age, it's got job, and then it's got these two underscores, and then it's got bin missing, bin 1, bin 2. Well, we actually want to separate those out because that's going to help us in the visualization piece. So that's what the separate function does. We're taking the feature column and we're separating it into two different columns called feature and bin, and we're using this double underscore as the separating. So when I do that, I've got feature and bin, and then I've got term deposit here, my correlation. So then what I'm going to do is remove any of the NAs, and then I'm going to filter and I'm going to detect anything with term deposit. I'm going to remove that because we don't really care about that feature because that's what we're correlating everything to. Then we're going to arrange it by the absolute value of the correlation. So we can see that now this duration feature is at the top, this bin 4, and that's got a 0.318 correlation. We've got P outcome success is 0.307. So these are our highest features, and right there is actually the result. But we don't want to stop there. We want to be able to visualize it. You never want to just give somebody a table of correlations and tell them to kind of figure things out. So that's what we're going to do with this next piece. We're going to convert this column into factors because factors are very useful for visualization. And that's kind of like a fundamental principle. So we've converted these into factors now, and now we're ready to visualize. So I've saved this correlation table. Here's what it looks like now, and we're going to turn this into a visualization using ggplot2. All right, so how we do that, so we've got this feature, bin, and term deposit yes, and we want to turn that into this visualization. Do I have it up here? No, I don't. This is the visualization that we want to turn it into. Here we go. We're gonna make this. So how we do that is we take the correlation data, and what this first piece does is it sets up the canvas. So what we're doing is we're taking this term deposit, yes, and we're setting that on the x-axis. So that's down here. Then we're taking this feature column, which is right here, and we're putting that on the y-axis. And then what I'm including is a text variable, and that's going to represent the bin. So if you remember here in this visualization, we've got this text here. So that's what's going to allow us to create the text. And then we're going to start adding some stuff. So the first thing that we're going to add, so now that we've got this kind of canvas created, we're going to first add a V line, which is just a line at the 0 axis. And this is just going to help visually tell, have us tell where the correlations line up. Next thing, we're going to add some points. So what this is going to do is add the points to the visualization. So because we've done the hard work up here, formatting the data properly, using these features, and we're now able to get each of the points for example, duration. We're getting all the different points for each of the different bins that are in here. The next thing that we're going to do is we're going to use this function called geom_text_repel. And what this is going to do is it's going to add the text. And what this does is add all the lines and all the different text here, so we can see, which bins each point corresponds to, and so on. So in just a few lines of code here, we've already got this correlation funnel visualization being developed, and we can already see right here, these are the ones that we want to focus on that are the most highly correlated to term deposit, duration, and P outcome. And the last bit is just some formatting. So we're going to expand the limits from -0.4 to +0.4 on the x-axis. So negative 0.4 to positive 0.4. And then we're going to change up the theme. This is my tidy quant theme. So that just gave it a white background. And we're going to add a few labels for formatting as well. So this adds a title, a subtitle here, and an x-axis, and converts the y. It gets rid of the y-axis title. So right there, we've got our visualization. So that's visualization number one that we're going to use. So now that we've got this information in hand, what we can do is then interpret the correlations. So the next piece here is we see bin 1, 2, 3, 4, but that doesn't really help us. What we need to know is what's in those bins. So this recipe object that we created, which was used to create those bins, when you pipe that into this tidy function, it outputs a data frame that tells you each of the steps and has a step number. And what I want to know is what happened inside of that discretized step. So that's step number 2. So when I pipe recipes into the tidy function, it gives me each of the values of those bins. So what I can then do is save this as a variable. And because I'm interested in duration, I can filter that variable for terms that equals duration. And when I do that, I can then see, oh, okay, these are my 4 bins. One goes from negative infinity to 103. That's this first bin here. The next bin goes from 103 to 180. So this is the amount of days since we've contacted that person in the past. So that's bin 2 is 103 to 180 days. The third bin is going to be 180 to 319, which is right here. And then the fourth bin, which is what we're interested in, is 319 to infinity. So that's this fourth bin. So what that tells me is that when the person has not been contacted in 319 days, it's a good idea to reach out to that person, because they're probably very likely, in fact, they've got a super high correlation here of 0.35 or 38-ish. So they're going to be very likely to be in that term deposit group, the people that convert. So that's how we take this visualization and go right to business results. It's pretty sweet. And instead of taking, each one of these variables and looking at them independently to figure this out, what I was able to do is just build this visualization, which told me exactly where to focus my efforts on. So I know to focus my effort on this one and then this one. So P outcome, this one has the label produced. So we can see that this is success. So when P outcome equals success, and when duration is equal to more than 319 days, that's our strategy right there. So all we got to do is then convert that into code. So we've got this data join tibble, which is our untransformed data. What I'm doing is I'm selecting duration, P outcome, and then our target, which is term deposit. So duration, you can see 261 days, 151, P outcome unknown. We want the P outcomes equal to success. And then the term deposit, what we're going to do is now evaluate this strategy that we're going to implement. So what I'm doing here is, let me just run this code and I'll explain what it's doing. So what I just output is a new column here called potential. And I've classified people as normal potential when they are not greater than 319 days and not equal to, or not equal to success. P outcome equal to success. So everybody gets normal, which is what this line here does, unless they have this duration greater than 319, then they get this high potential tag, or P outcome is equal to success, then they get a high potential tag. So you can see that this person here has 380 days, although P outcome is unknown, which is kind of a negative attribute. They're in the 380 days, so they're in this bin 4. So we want to give them a high potential tag. So that's what this line does. The next couple of bits here. What we're going to do is assess the proportion or the probability. So we're going to group by potential, which is this new column here. And you can see it's got, this table now has 2 groups, potential 2. It's got 2 groups. We're then going to count the term deposits, meaning no's and yeses. So that's what we've got here. So for each of those groups, which was no's and yeses, we're going to count the term deposit, whether it was no or whether it was yes for each of the different groups. Then we're going to add a proportion on here. So for this high potential, but that term deposit outcome was no, we can see that that's 8,364 people, and 68% of those people did not take the term loan. Conversely, high potential equals, potential equals high potential, and term deposit is yes, meaning that they actually opted into that product. That's 3,887 people. So when you add these 2 numbers up here, 8,364 and 3,887, and then you take 3,887 divided by that 12,000, which is just the sum of these 2. That's how you get this 31, that proportion, 0.317. So we're getting 31% yield out of this high potential group versus the normal group, which is only 4%, which is this number right here. So what we're going to do at this last couple of steps is just kind of clean that data up, and we're going to add an additional column called labeled text, and this is, and you'll see why when I make the visualization. All right.
Hey, Matt, we're at 3:55. Just a heads up.
Okay, this is the last piece here that I really want to show you guys. I'm just going to run this code. And what it does is it takes this data frame and basically converts that into this plot. So what this plot tells us is that we've got 31% yield out of these people that we've identified high potential. That was based on this plot here. So what we did was we converted this correlation analysis into a strategy. And when we implement that strategy, again, this is not on a holdout data set, but this is on, you know, what we've seen based on the data. It seems like there's going to be a strong likelihood that we're going to be able to increase the yield. So 31% versus 4.3%. And that was basically just with a simple correlation analysis, implementing a business process into R. All right, just real quick, I do want to show you the RMarkdown. And this is cool because once you create that R file, you can actually integrate it into a file that contains, it's called RMarkdown, but it has text. So what I did was I copied and pasted the code in here and the visualization code, and I added a little bit of text here. And when I click this knit button, it pulls up an actual report that I could give to my boss. And this is what their report looks like. So it's got the strategy here. It's got kind of our executive summary, and that's what I showed at the beginning. So that's really what I wanted to show you. And also, if you want to give it to, say you're not giving it to your boss, but say you're another data scientist, we can change this echo from false to true and rerun the document, and it'll actually have the code in there too. So now we have all the code in here, and people can actually reproduce my analysis. Okay, I know that was a lot, but what I wanted to show you guys was exactly how RMarkdown and R can be used to take a business process and convert it from Excel into R. And I know it's probably overwhelming if you haven't been used to R before, but that's really where I think the plan comes into play. So let me go back here. We've got a plan for you. If you're interested in actually implementing some of the tools you've got the code. You can actually just kind of rinse and repeat it. All of the codes up here, you just take this code. You can get the R file right here. You can get the RMarkdown document right here. And you can actually reproduce everything that I've done here in this presentation today, and kind of go through that process yourself. But what's probably going to happen is you're most likely going to want to learn R and actually understand, so you can customize this in the future for your particular needs. And that's where this plan comes into place. So we actually offer through Business Science University 3 courses that take you from literally knowing nothing about R to being able to do everything that we've done in here, plus make shiny web apps, plus do advanced machine learning, which we did not cover. So this is the 3-course system that we've developed. The first course is Business Analysis with R, and that is a 7-week course on data science foundations or fundamentals. And in that course, what you do is you learn how to clean data, manipulate data, do the visualizations. So all the visualizations that we produced. You also learn how to do business reporting with RMarkdown. So that's the first course. The second course is the Data Science for Business with R course. And that's what that is an advanced course where you learn machine learning and business consulting. It takes about 10 weeks to complete, but you learn the recipes package that we talked about in here. You also learn H2O, automated machine learning, and you learn advanced visualizations, wrangling. And then the last course is the Shiny Web Apps for Business. And that is web application development. That's a 6-week course where kind of take your machine learning into production, and it shows you how to do that. So that's kind of the program that we have for you. If you're interested in taking R and actually applying it in business beyond, just kind of rinsing and repeating what I've done in here for you in this learning lab. We're going to give you a special promotion code for your time here today, 15% off. It's Learning Labs, all one word, and labs is plural there. So it's going to knock the price down 15% on each of the different courses. You can get the 101, which is the foundations. We got the 201. The 301 is not quite available yet. It'll be available next month, which is the Shiny Web Apps. And yeah, so that's pretty much it. That's the bonus that we have to offer you today. Learning Labs is the promotional code, and it's university.business-science.io if you're interested in those courses. All right, I know that was a whirlwind. Let's hit some questions.
Okay, great. So yeah, I was over here like frantically trying to answer as many as possible. So let's get about 4 or 5 in. I think some of the more common ones that maybe some other people may be thinking about. Mike Thompson asks, how do you know that duration is optimally binned? Can you explain?
So the duration may not be optimally binned. That's one of the kind of like the deals with basically what it's doing. That quantile, that discretize step here is just picking bins to fit each one proportionally. So that way bin 1 has the same number of observations as bin 2. So if we think about like our data here, for example, so duration is maybe has a range of say 0 days if they were just contacted today, all the way up to say 600 days. Maybe that client hasn't been contacted in 600 days, and that's your highest. So what it'll do is it'll pick those quantiles based on sectioning that data into proportions, meaning like 4 groups of 25%, and then lumping those observations into each one of those bins. So that's how it's done.
Okay, great. Okay, let's see. Does the 201 R course cover the 101 R content? I'm asking because I already work with R, but I would like to be more effective.
Sure. So the 101 is and 201 are completely different, meaning they have different business problems. The skills that you're learning in the 101 is going to be you're going to learn dplyr inside and out, because that's a 80-20. 20% of the functions that you learn produce 80%. So dplyr is hit very hard because you're going to be using those functions so much. You're going to be learning ggplot2 inside and out, meaning I think that week there's 45 or so lectures. And it really takes you from the beginnings of ggplot2 all the way through some advanced plots like heat maps, and some advanced, a more advanced lollipop chart and those types of things. It also goes into like how to adjust the theme elements and those things, which are like very structural things that you need to do if you want to make complicated visualizations, but it does it in a very manageable way. The modeling section, which I'm getting ready to release hopefully this weekend, that goes through kind of linear regression, random forest, and k-means clustering. And these are topics that aren't really talked about, that are more basic in the business analysis course. But once you get to the advanced machine learning, you're using H2O, automated machine learning, which implements all of the best algorithms. So they're kind of different. The 101 is more, it's going to hit you real hard with the fundamentals, but honestly, that's what most data scientists need. The 201 is going to take you through an end-to-end business process where it's one problem and you walk through every step of the way. And David, you took the 201, so you know.
Yeah, I was going to jump in when you finish. The 201 doesn't really hold your hand a lot. Matt does explain certain libraries and some of the functions within those libraries, but if you're going to take the 201, you want to know R syntax. I think you would move along a lot faster with it. If you don't know the syntax, if you don't mind sort of pausing the video and trying to figure out a few things yourself, it can work. But you know, we all learn a little differently. If you want to just be able to fluidly go through the whole course without having to figure stuff out on your own, start with the 101. And because it does a good job at explaining everything slowly. And then by the time you get to 201, it'll just be, some of that stuff will be a refresher and you'll pick up on the new advanced topics.
Yep. Yeah. The 101 is definitely going to be a lot more hand-holding and really going to guide you in terms of every, all of the major functions that you will ever use in R and in the tidyverse. The 201, as David said, is less hand-holding, more, hey, this is how you do business analysis every step of the way.
Yeah. Okay. They still got some more coming in, but I'm just gonna, let's get through a couple more here. Oh, this one I meant to answer. David, I'm looking for a marketing analytics book recommendation in R or Python. I read the R for marketing research and analytics book. I'll put a link to it in the description. I mean, in the chat. It's a little, it depends on what kind of marketing analytics you're looking for. I think this book does a good job at introducing you to R and data analytics, and then interweaving some marketing concepts within that. So it's like you're learning R and analytics through marketing projects. But the marketing projects may not be specific to the type of marketing that you want to do. Like, I think it'll do segmentation and some other common stuff, but some stuff it's like you would have to be in like a large enterprise to be interested in. The marketing analytics I do is more in digital marketing. I do data analysis with like search engine optimization data. I do like social media analysis, stuff like that. And there's no books on that kind of stuff. You have to sort of piece it together yourself. So, but anyway, the marketing research, oh, Bryant put it in the chat. Thank you, Bryant. It's a really good book. I do recommend it. it's a great primer. However, if you're looking for modern marketing stuff, that may not be the book. Well, there are no books on that from what I've seen. But anyway, that's a good one. Okay, let's get like 2 more questions in here, and then we can wrap it up. Oh, so this is by Emily Yang, and there was a couple more people who had a similar question. What is the name of the statistical test you ran for the correlation analysis? For example, for continuous data, linear regression is typically used with the Pearson coefficient as outcome. What is the one that this one used? What is the name of the coefficient?
Sure. So what I did was instead of running like the t-test or the Pearson test or anything like that, what I did was I just simply looked at proportions here. And what I wanted to know was, basically assess visually with this graph, is there a difference between the population that is quote unquote identified as high potential versus low potential? So that is the one piece here. And then the other piece is like in the core, the actual core function. So if I search question core, oops, don't select core data. But if I do question mark core, this is the help documentation. And you can see that it's got this method here, which is Pearson, Kendall, or Spearman. So the method being used underlying that actual function is the Pearson by default. So that's what I used, was just whatever the default was. So correlation in this function, Pearson, and then the actual proportion analysis, which is this plot here, that was just kind of basically looking at the different proportions.
Yeah. All righty. Okay, so we answered that. Done. I'm scrolling through all of these, so bear with me. So for everyone who's asking about the video, yes, the video links to the code, links to the slide deck will all be emailed out, and it'll also be available on the Business Science website. So if for some reason you don't get the email, or you can always check the website.
Yeah, and I know this lecture, more so than the past, is more technical. It's definitely something that we're going to give you guys the recordings, and then you're going to have access to all of the materials too, so you can go back through. And it's a lot to compress in an hour, but I'll tell you what, go back through the code, learn, watch the video again, and kind of go step by step through it. It might take you an hour or two, but honestly, like, that'll lock in the learning. So everything that we went over today, it'll be you'll be able to kind of step down through the code as you rewatch the video. That would be if I was in your shoes, that would be what I do.
Okay, and then let's just do this one as the last one, because I'm not sure how to pronounce your name. Sorry if I get this wrong, but I think it's Gaurav. He's asking, how do you perform the VLOOKUP equivalent when we did the reduce left join?
Yeah. So the VLOOKUP,
we've asked that a few times, so I want to make sure we get that in.
Yeah. So VLOOKUP, how we do that is if we take if I just take one data frame. So say I've got let me take our data joined. I'm gonna split this data up. So I'm gonna do data joined, and I'm gonna select ID and age. So basically what I'm doing is taking this ID and age column, and I'm gonna make this TBL1. It's for Tibble 1. And then I'm gonna make Tibble 2. TBL2, and I'm just going to copy this, and I'm going to give it some new columns. So I'll do say ID, and we'll say education. So I've got Tibble 1 here. I've got Tibble 2 here. So these are my two tibbles that I want to join. So how I would do that is I do tibble 1 left join tibble underscore 2. And because they both have the same ID column, what I can do is I can join those based on that ID feature. And you can see that when I do that, tibble 1, pipe that into left join tibble 2, is joining by ID, and it's actually mapping those two. And then what I could have done was do this manually 4 times. But what this section of code does is just actually looks through each one of those sheets, the sheet names, and then it uses this map function to read the Excel, and it actually returns these as a list of tibbles. So we've got one tibble here of 45,000 by 5, 45,000 by 5, 45,000 by 9, 45,000 by 2. And then what I do is I use the reduce function, which just applies left join to these first 2. And then whatever the result of that first 2, it then takes that and applies it to the third one and to the fourth one. And that's how we get that VLOOKUP equivalent, just really quickly.
Okay, so these are going to be the last 2 questions. Sort of.
I'm happy to answer them all, though. Seriously, I have plenty of time. If you guys.
Okay, all right. So I was taught to approach. This is a good question. I was taught to approach correlations with caution. Correlation not equal to causation was jammed down my throat. Is there a different test that we would use to approach this business problem? And I guess the idea here is, how do we go about confirming our correlation analysis?
Yeah, so what you would do, like, honestly, this is just the tip of the iceberg. So in my 201 course, for example, the correlation analysis, what I use that to do is just confirm that I've got good features. So if we look back at that plot of the correlation analysis, I've got some features that are in the positive. Certainly, like if all my features were in this like 0.0 to plus or minus 0.03 to 5 range, then I'd be a little worried. But it looks like I've got some really good features here. So what I would actually do is use this as the beginning stage for a machine learning analysis. So in the 201 course, once you identify that you've got good features, which we can see very clearly here, we've got some good features. Then I would run it through like H2O automated machine learning, which you learn in, I think, like week 5 or so of the data science for business 201 course. So that is then what the next step would be. So you run it through a machine learning analysis, actually coming up with a model that predicts, and then you confirm that it works on new data. And then you would perform another analysis called LIME, which is actually understanding specifically which features for each of the different people are contributing to that term deposit or not. So that's what I would do. I would use this as the basis for an even bigger analysis, which is with machine learning involved.
Okay, and then last question from Jason, and this kind of, actually the previous question I think leads into this. If you had a date field in the term deposit data set, how would you approach splitting the data into training and testing to improve the potential success and yield projections and set up for monitoring success as you keep getting data results in 3, 6, 9 months, et cetera? I think he's asking, how do you, because I believe this would sort of lead into the machine learning part about splitting it into a training and test set, but then also accounting for time series.
Yeah, so time series is especially difficult because what ends up happening with timestamp data is over time, things tend to change. So what we call that is a regime shift, meaning that say the first part of the year, sales might be flat, and then all of a sudden it changes. So you have to be careful on how you model that. And what you typically want to do is you want to take sections and then predict the next following section. So you would do one section, say as the first quarter, and then try to predict the next quarter. And then the next group would either shift and then take that second quarter and try to predict a third quarter, and so on. That's how you would normally do a time series data set that you're concerned about, those regime shifts and checking how good that model is.
All right, that's it. Oh, the last thing for Jess, she said, did I miss where strings were converted into factors? And I said that for this exercise, we skipped the whole sort of data wrangling phase. The data was sort of pre-cleaned. For this exercise, we just really wanted to show you how to get Excel data in, do a correlation analysis. So we didn't bother with converting data types and everything. We just went straight into it.
Yeah, and I think what ends up happening too is under the hood here, this step dummy will take those character, convert it to factor, and then turns them into dummy variables. So that kind of categorical encoding is already, it's all taken care of for you with the recipes package.
Okay, I think that might be it. This was pretty good. A lot going on. It was pretty intense. I feel like folks were like quiet for a while. I was a little concerned.
Yeah. Well,
it was good stuff.
I know it's a lot of information. You guys will now have the video to go back. And then honestly, like if you want to learn this stuff inside and out, we've got the program too for you. So that'll really help you. If you're interested in really being able to do everything that I talked about in this lecture, or this learning lab, then the courses are honestly, that's what I would recommend.
Yeah. And the one cool thing about this coding exercise is you also get to see Matt's style of how he works through problems, because what you saw here is exactly how the courses are built, with a little bit more interaction with looking at some of the documentation and explaining things, but it's a good taste of what to expect from the courses.
Right.
So yeah, thanks so much, guys. This was a lot of fun.
Yeah, thank you so much. I'm really happy with how these learning labs are going. So we're going to continue to hopefully give you content that you guys can use in the future. And I hope this one was worthwhile for you.
Yeah, so we look forward to seeing you in a couple of weeks for the next one. We will announce the topic pretty soon and hope to see you there.
All right. Thanks, guys.
All right. Take care.